All right, I think we're live. Let me just send a couple things out real fast. And that there. And what's that? Go to Twitter real fast. Nope, not that one. Okay, tweet that. All right. Get that up. Sorry, let me get some of the stuff kind of straightened out here. It's been a little while since I've streamed. So, in today's stream, I don't know how many of these I'm going to have time to design today, but I've got an idea for like a new line of products. And they're all kind of in the same family. Let me go to my main camera. I've actually already kind of designed a couple of these. Got this one, got that one. They look identical, but they're actually not the same in that they have different sensors on them. So it's the same base um, product, but I'm thinking about having different ones that have different sensors on them so that you don't have to plug things in and it's all just in like a little convenient package. And I'm trying to make them small too. So that's what I'm going to kind of work on today. I've done these two um, like test designs and they work, but I'm not really happy with the overall layout. So I'm going to change that. I'm going to redesign the layout a little bit. And then if we have time, maybe make a few different ones with different sensors on them. So that's where we're going to get started. This one, so one of them has a temperature and humidity sensor on it, which is that little thing up there in the corner. And the other one is an accelerometer. I can get to focus. Come on. There we go. And that's up there in the corner as well. I'm debating whether or not I want to keep sensors up in like the corner. Ideally, I'd like to keep the sensors in kind of the same place on the board on all of them so that everything else can stay the same as far as pinouts and whatnot. I'd also like to add a stemma connector to these, which let's see if I have one laying around here. They're basically the type of connectors on like Adafruit and SparkFun boards that make plugging those in super easy. So let's go back to the desktop here. This one is the temperature sensor. This schematic is a mess, so let's not concern ourselves with that so much. This is kind of the original layout, but I've added the stemma connector, but it's not on here very well. I have to move some stuff around. So that's what we're gonna do. Also, a lot of this stuff is 0402 components, which is fine, but there's kind of like a weird gap in here where things aren't really well laid out. So, kind of debating whether or not I just want to wipe all this and start over, um, which might not be a bad idea. I mean, some of it's kind of close where I'd want it, but I think the first thing we're gonna do is just kind of I'm gonna have to make this board a touch bigger, which isn't the end of the world. Um, nope, I don't like that. Nope, don't like that. Don't like that. Trying to. Let's see. Let's go down. Maybe that far. Grab the corners here. to change the grid size. Okay, we'll connect these up. Okay. Well, actually, I might be able to. We're going to move this one down here. And then this one is later. Wow. Usually doesn't let me drag all that stuff without it throwing a hissy fit. So let's. Oh, I guess maybe it. I guess it isn't letting me do that. Just like to. Okay, well. Do it the hard way, I guess. I don't know if it'll let me do it now. Nope. Okay, jeez. Be nice to be able to drag some of this stuff without having to delete stuff every time, but let's come down to about there. Okay, delete those. Let's refill. This. All right, so connect a few of these. And that's okay. Goes there. Connect our grounds, even though they're I think they're technically connected already. Okay, and then our V bus, which let's get that here. Okay. Clean these up maybe a little bit. Actually, I think I can over here. Okay. So, and let's do this. Trying to make these a little more symmetrical so it looks a little bit better. Okay. So these here are buses, which we can drag down out of the way. That's good. Okay. Now, as far as our reset buttons go, let's move these off of here for now. Clean these up. Okay. Got those. V-band, V-bus. So we have kind of like a gap here. More room down here now. Couldn't see it the schematic. So this is the light sensor. We don't need that. Let's get rid of that. Date, tools, cleanup. Date, okay. All right. That's our charge controller. Or our LED rather, status LED. So we might be able to take some of this. Oh, geez. Didn't like that at all. Let's go here. Grab that stuff. And rotate it. Here. Clean up our tracks again. So we don't need all that stuff. Okay. Some of this is not going to be very pretty, but I'm just trying to clean this up a bit. Okay. We'll leave that there for now. Okay. All right. Let's see. So. See where some of this would make sense to keep things where they're at. Or not. Don't like the way that's laying. Okay. What's going on here? Let's just redo it. Okay. And we got VBus over here. Just kind of rearranging some stuff. This. Let's put this down here. Where's that one going? Way up there. So really, I don't think I need these going underneath anymore. Okay, we'll see how that shakes out. Okay. Actually, We're probably gonna have to move that one, I would think. Um, so got a reset. Can I fit these in here like that? I can. What about this? Trying to find the correct room for everything. Move that in a bit. That. Okay. Got that. Got a lot of space over here. I wonder if half of this is just trying to find places to put things. That sensor works up there, but I wonder. So the idea is that since I want to have different sensors on different ones, but I want to keep the same form factor. I need to account for larger sensors. This temperature sensor is fairly small, so being able to get something bigger up here would be a problem. So I need to leave room somewhere down here, I think. And ideally, I'd like to get this mounting hole somewhere else. I've got one mounting hole, but it'd be good to have two at least. So, these. That is the big question here. Got all that up there. Oh, excuse me. The other thing I would like to do is use the bigger. Let's go over here real quick. Change the footprint. I think it's. No, not that one. Not that one. I think it's 373. I think. Or no. This one. Pretty sure it's that one. Date. That one's considerably bigger, but that's fine. And let's get rid of references. We don't need those. And then the other thing is the Schottky diode. I think that's the smaller one too, if I'm not mistaken. Yeah, it looks like it. I think it's. I think it's 3. Let's use that one. Let's try that. It's considerably bigger. Okay. Move some stuff around here. Can't really move these too much. Okay. Get rid of that. Try and make some room here. Feedback goes there. Of course, it's not gonna. Move that over a little bit so I can make room here. Those. And of course, that still doesn't fit. Gotta make a little more room. Okay. Go. Okay. That's a bit better. And kind of move these over a little bit. So bring this up. So let's go and connect. Come on. Okay. And this one is, whoops, did not mean to hit the mic there, sorry. That's the status. Okay. We want the flows through there, goes to Vin. Let's enable. Okay. To separate these just a touch. Nope, I do not want to go underneath. Nope. Okay. Go. There, we got that. Oh, nope, 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 nope. Do this. All right, no, let's not do that. Okay. Yeah, we need to connect those. Okay, that shouldn't be too bad. Let's here. Okay. So feedback's going up through here. To or is this? Yeah, that's VBus is still not connected. We need to figure out the. Okay. Okay. Just trying to think out loud here. So that goes there. VBus comes down here, which we can go underneath. Okay. And we'll take both of these under. Oh, geez, getting it up in there is going to be fun, though. Guess it fits, technically. Then this one's going to be kind of the same way. And this one, we can do blue for that one, because that one's got to connect up the bottom anyways. Okay. So we got our reset. Gotta go up. Oh my goodness. Now we need to decide where we want to put the sensors. I kind of wonder if do those there, maybe. You know, that leaves kind of the center section here for the a little cramped though. They're connected, so move that up a little bit. Delete the unused tracks there. Okay. Probably gonna have to okay, so put those there. Okay. Now the temperature sensor, according to the data sheet, should basically not be surrounded by, like, basically if the PCB needs to be cut out around the sensor as much as possible. In fact, I even have a Adafruit example, which I can probably show. So if I can get that to focus. See how that's the PCB's cut out around the sensor itself. That's something I have to take into account because at least up here it kind of, you know, worked for itself, you know, on this design. If the sensor's kind of cut out up there. But as I was saying, if I want to add other sensors to this board in replace of this, they'd have to fit within this footprint, and that's pretty small. I don't think most of the other ones I'm thinking about doing will fit there. Lux sensor definitely will not. Air quality. Air quality probably would. It might fit there. That's a good question. So I'm thinking about doing, I mean, I have like a laundry list of different sensor ideas to put on these boards. Got a temperature and humidity sensor, which is this one. Got an accelerometer, which is, this other one that I made. There's a lux sensor, which is a light sensor. I could do like a lux or and UV type sensors if you wanted to track that type of stuff. There's air quality, altimeter, gesture, proximity, microphone, and time of flight are the ones that I have. I don't know how some of these would be, useful to some people or not, but those are the ideas I'm kind of floating around. 1 second here. I guess. I guess probably what we should start doing is just throw all the different sensors that I'm thinking about doing on the schematic here, and then we can see if their footprints fit. So I might end up, in fact, I'm going to put that back where it was. Okay, let's see here. What is it? It's GP 30. Okay, so we have got, this is the Mach sensor, gas sensor, which is, it tells you your VOC of air quality and things of that nature. So let's see if we can see if they have ECAD models. Thinking about it. Okay, select our. Come on. Just go to the librarian directly. Let me log in real quick. Okay. This one. Okay. Here. Download KiCad. Both of those. Download. And let's see. Okay. Those are downloaded. Get the 3D model while we're at it. Thinking about it. Okay. Let me look at my list here. See what else we got. UV or lux sensor. Which I'm trying to remember which ones I have. Let's see here. Close that down for a second. Is it this one? Oh, it's infrared. Okay, get this one. See if we can find this one on. No, we can search it, see if it shows up. Yep, it's that one. And trying to. Did I close it down? log back in. Oh, okay. Didn't have to actually click on anything. Get this one. Let's download this one. Basically just gonna go through and collect some of these different sensors and then throw them in the schematic or on the footprint and just see if they all fit within that kind of general area. So if anybody's joining and curious what I'm doing, I'm designing basically a new family of products where the idea is going to be, I'm calling them, a B Mini, and they're all in the same form factor, but they have different sensors built into them. So I like to keep the same form factor from all, but change out the sensors basically. So got those. And some of the ones thinking about doing, we got temperature, we've got accelerometer, which are the two that I've already kind of made these original test cases. Air quality, lux or UV light, altimeter, gesture, proximity. There's microphone. There's time of flight. It's a whole bunch of different ideas. I don't know how many of these I'll do, but because I'm sure some would be more popular than others. Last thing I want to do is make a bunch of boards that nobody wants to buy. So, trying to see which one was the. I've got a bunch of different sensors here. Trying to figure out which ones. There was a particular altimeter one I was going to use. What did I do with that? Here it is, I think. Desk is a mess. Okay. Which one was it? DPS 310, that's what it was. So let's see, DPS. See if that shows up on here. Nope, not 32010. There it is. Okay. It's a 3D model. Okay. And KiCad. Let that download. Okay. So let's throw a couple of these in now, just so we have them. And hold on a second, let me do this off screen. Okay. Come on, stupid thing. Not cooperating. Let's go. And we're gonna go KiCad parts. Okay. Window. Just bear with me for a second, guys. That's the step 4. Oh, I had both of them in there. Okay. So let's. Folder. Yes. 10. Okay. Back up. Go. Was it BH 1750? There. 1 second here. New folder. SGP 30. Okay. Isn't there? All right. Got those. Now, let's footprint. Let's go to symbol. Need to add some new symbols. So I'm going to library. Okay, CAD. Okay, didn't like that. Library. Okay. Import symbol. Let's see here. We got BH. Okay. Save that one. Let's go parts. This one. Okay, save that. Import. What was the other one? SGP30. Okay, save those. Then we're just going to add those to our schematic here. I'll just do them off the screen for now. Symbols look very familiar, or very similar rather. Good if the pinouts aren't that much different. The other thing we need to do is we need to add the footprints for these because that's really what we care about. User, import footprint, KiCad, parts. So one is BH15. Okay. I don't know why I never actually saves it. Let's just get rid of that for now. Okay, BH15, save that. Do another one. Import footprint. So we got that one. We need this one here. And save it to our user folder. And then this one here. File, import, need, was it SGP30? Okay, save this. And we'll leave that the same. Okay. So this one we can set up the footprint. User. Okay. That. TPS 30. Okay. And that one. Okay. Save. Tools. Update schematic. Boom. Okay. So these are the different sensors so far. Come on. A lot of these look like they might. Oh, come on, stupid thing. A lot of these look like they might actually fit in there. Let's see. Turn all this off. Okay. All right. So let's take a look here. That would fit in there. That'll fit in there. So all those will fit. We know the accelerometer fits. So I might get away with just leaving them all up in that corner. So we've got an altimeter, we've got air quality, and we've got, what was the other one? Air quality, altimeter, light. That was the other one. So our other options are a gesture sensor, proximity. What do we got here? Microphone, time of flight. If anybody has any ideas, leave a comment. Let's see. Let's see. I think a gesture sensor is kind of big. Let's see how big that one would be. Yeah, it'd be this one. So let's copy that. Let me show you what I'm looking at here. Let's this one. What's the difference here? Not available on Snap EDA. The model is, which is odd, but not an exact match. We are looking for. That's the one we want. So what? I wonder what the difference is here. Huh. They're like itty bitty guys. Okay. That one's not showing up. Let's look on Snap EDA and see. Give me a second. Let me oh, it might actually be on here. Bring this over here so you can see what I'm looking at. Okay, that might actually be it. Let's go KiCad, V6 for later. And the footprint. KiCad, 6 for later. Okay. So now let me install these real quick. Copy those to parts. New folder. That one is APDS 9960. Paste those in. Okay. Let's go back to our schematic. A lot of back and forth here. Just trying to get all this stuff entered in. So, user, file, port symbol, parts. Okay, save that. I'm going to add the footprint. Okay, and let's go footprint. User, save. Okay. Then we can add it. User, save. Oops, nope, don't add it again. The footprint. Going to that one. Tools, update, schematic. Okay. So that's the gesture sensor. That would fit there too. That's good. So far everything will fit in that little peninsula, I guess. What was the other one? There's time of flight. And yeah, because this one is technically the one I just added, the APDS 9960 is a proximity light RGB and gesture sensor. I guess it kind of kills the same bird with a bunch of stones. Oh wait, does that make sense? I think I just screwed up that analogy. So I'm looking at the data sheet real quick. Or yeah, we'd have to see. I'm kind of curious because I think I have a few of those floating around. What all it actually spits out if it's just so we got that one. Bear with me while I look through my assortment of, there it is. Assortment of breakout boards. I've got a bunch of them. And I do mean a bunch. Okay, so let's plug this in. We'll upload some code to a board and just see what it spits out. Get an idea, because we might be able to combine. Sorry, I'll get on the right. Okay. I'll plug this into one of my. I'm literally just plugging it into one of my boards. I have a little breakout board with that sensor on it. Oh, not that one. Crap. Is it still recording? You're still streaming? I accidentally hit the lock screen on my my computer. Didn't even hesitate to close it. It's like, all right, no problem. Okay, so let's open up Arduino here. Arduino. Here. Here. Oh, okay, awesome. Still streaming. Thank you very much, Nicholas. I can turn this on so people can see what you're saying. Okay. That was a fun adventure. Let's see here. Let's go to examples. I think I already have it. Yes, I do. So color sensor, gesture sensor, and proximity. So let's do color first. Get rid of this stuff. I am going to have to add this for library for my board, just so it turns everything on correctly. Okay. Let's open up Motion S3. Put it into download mode. Okay. Let it compile that real quick. I'm just curious what data this sensor actually spits out. Because having like a dedicated light sensor, if this one will do the same thing, kind of seems silly. But we'll see. I was thinking about it. There we go. Okay. And let's open up the serial monitor. Give it a second. I'm streaming. Oh. Yeah. Hi. Hey, wife says hi. Hi. There. Hello. Hi there. Rub your head for good luck. Thanks. Get back yes. To work. This is what everybody tunes in for. Yep. Come on, want this serial monitor to spit out some data, please. Nicholas says hello. Come on. Am I doing something wrong? Including that. Got that. On port 34. Trying to get the, I don't know why my serial port's not opening up or working. Let's plug. Okay. I unplugged it and then all of a sudden, or I unplugged the breakout board and all of a sudden the serial monitor started spitting out data, which wasn't correct. Why is it doing that? That's weird. That's unplugged. Like it's not even plugged in right now. Plug it back in. What's going on? Let's try a different sketch with that one. That's weird. I know the board works. I was using that the other day. Let's try this one. Let's grab this. And put in the begin. Okay. That's upload. Unless the board's bad, or the breakout's bad, which I think I have more of that same sensor somewhere. I might try if it, yeah, there's another one. I don't think it's a capacitor thing because I literally had different of these breakouts literally plugged into this a little bit ago that I was doing other stuff with the other day and it was working fine. So we'll see if okay, that didn't do it. Let's plug in the other one. Okay. I think everybody tunes in to watch me struggle to get a serial monitor to turn on. What the heck? I wonder if grab a different one. Just out of curiosity. That didn't work. Which ones of these are usable? Okay, plug that in. Let's try a different board. Okay. I think all I want to see is just what data this thing spits out. Okay. It's on the right port. Right. Maybe a different cable. Come on. COM 34. This one's on COM 195 for this particular board. Basically, when I test my boards, I have to like when I upload test code to them and test them, and then put the shipping firmware on them. Every time it does that, it enumerates a new COM port for that particular board. So I've gotten all the way up to like 1,000 before, and then I have to go into my registry and edit the COM ports to get rid of them, so I can start over again. Yeah. So I have a buttload of COM ports sometimes. It should be working though. I wonder if I put that before, maybe that's the difference. If this doesn't work, I'll just move on. I don't know when I'll keep messing with it. But it should work. COM 95. Huh. That is really weird. I wonder if the baud rate's the same. I wonder if I should do a while loop while it's waiting for the serial port to open. I think it's... I think that's all I have to do. It'll tell me if there's an error. So basically, you know, what it should do is like it shouldn't initiate anything else until I have opened the COM port. Which it didn't give me an error, so I think that's the right code. Okay. Failed initial. Okay, so that's off to a better start. Um, failed to connect to the device. It's got power. Okay, maybe all this fun troubleshooting. Try that. So it should wait till the serial port's open. Once it's open, then it should initialize the library. So, okay. Why? Come on. Hmm. It's turning on the little breakout, but for some reason it's saying that's not right. Which doesn't make any sense. Huh. Let's... I know this is riveting. I'm sorry, guys. Should work, though. Let's try a different one. Do this one. I was using this one the other day. Actually, did I? Open recent. This one. Okay. This one I literally was using the other day, so it should work. That'll tell me if it's the board or if it's the breakout itself. I'll compile that for a second. Although I don't. Oops, I don't have that one plugged in. That's this it? That's not it. It's this one. Okay, still compiling. Come on. Shouldn't take that long to compile, geez. Come on. Let's doing that. Let's I don't want to reset it, but maybe I should. Port 194. Sketchbook. Open recent. This one. Don't save that. Tools. Okay. There we go. That's better. Kind of wonder. Okay. Okay, that's uploaded. What the heck is going on? I wonder if it's that cable, maybe. Got some power there for a second. Huh. Something weird's going on. I literally was using this like a couple of days ago and it was absolutely fine. Working exactly as I intended. It's not showing any power there. Oh my god. That might be part of it. Let's try this one. Tools. Let's... Yes, I did. Reset. That's got the power light on, which is a good sign. Okay. That does work. Jeez Louise. That was an adventure in and of itself. Okay, so that one's working. Now let's... I'm gonna kind of copy some of examples. This library. Let's do the color one again. Get rid of all that. This. And do this. So after that, okay. Close that one. To unplug that, plug in the original sensor, and okay, download mode. All right, back to the original one. Letting it upload. Thinking about it. All right. Port 34. Lights on. There we go. Jeez Louise. That was a lot of Okay, so that one spits out red, green, blue, and clear. I don't know how useful that information is, but I gotta, let's see what we get here, because I got a green light I can kind of put this in front of. Yeah, it's saying getting a lot of green, a little bit of blue, which makes sense because the thing around the green light is blue. Okay. So for that light sensor, if we were to add it, it does proximity, it does gesture, it does color. So having an actual light sensor that gives you like lux or UV would probably still be useful. Okay. So what else do we have? We just wasted 20 minutes on that. Yeah, so those are the same gesture. Altimeter we got, air quality, light, accelerometer, temperature sensor. Time of flight was the other one. Which kind of crosses over with proximity, honestly. In fact, I'm kind of curious what the proximity on this particular sensor, what does that tell us? And proximity sensors you can actually set up to be a pretty far distance. Like I was looking at one that does like up to 6,000 millimeters, which is pretty good size, pretty good distance rather. I'm willing to bet this one is probably fairly short. We'll find out. Okay, let's do that. Download mode, port 193. And let's upload it. Because what's 6,000 millimeters to English metro or English 2 feet. Oh, I was gonna say I typed it in wrong. It gave me 6,000 meters and it spit out like 19,000 feet. I'm like, that's not right. About 19 feet, so almost 20. It was pretty decent. Not for this sensor, a different one I was looking at. Device initiated. Okay, initialized. Okay. Gonna give me any information besides just that? Thinking about it. Enable true. Okay. Oh. Okay, you're telling me it's initialized, but you're not giving me any information. Why is that? It looked like it kind of given me something there for a split second. I don't know if that doesn't do anything. It doesn't really do anything either. Stop, run. Hmm. Just having a field day with these little sensors. It says, hey, I'm initialized, but then doesn't give me anything else. Which, initialize means, hey, it's working, but it's not actually not printing anything. Pin mode. Here's the interrupt pin. Does this one have a... If we can find samples. Gesture. Sample. Where? So that one didn't have an interrupt pin for some reason. Does this one? Hmm. I'm sure this is... Put that there. Don't save that. Reset. Port 93. Upload this one. Oh my goodness. All right, this is the last one I'm going to mess with, and then we'll go back to designing. This particular sensor is that big of a pain in the butt to get working. It might not be worth putting on a board, but Reset. Okay. Same thing again. Initialized. It doesn't go beyond that. Yeah, once it senses, there we go. Okay. So that little arrow there is showing which direction it's. Yeah, so if I hold it like this. So that should be up. That should be down. That should be down. It likes the up direction a lot. There we go. There's down. This should be to the right. This should be to the left. Okay. So maybe I just needed to initialize on the other one, proximity. Which that me doing that, I have to be like right in front of it. So as far as a proximity sensor, that might only work if like you're literally sensing something that's, you know, that far in front of it, basically. So let's go back to the other one that we were doing a minute ago. It seemed like it wasn't working, but maybe it was. Gotta put this crap in here again. Although, I'm not sure about the interrupt pin. The pin that the interrupt is attached to. 3. Oh, we'll find out. Ports. That. Don't care about that anymore. Try it again. Oh, man. Okay. Reset. Port 34. Serial monitor. Okay, it's initialized. Let me see if I can wave directly in front of it. Not doing anything. Let me go to the Adafruit thing because this is their board. See if they see something about the interrupt. Okay. Huh. So whatever is my SCL pin, maybe? Let's see. 36. Let's try that. Okay. Oh. Okay. Okay, it's initialized. Huh. Proximity, for whatever reason, doesn't want to work. Okay, well, that was enough fun for messing around with that. All right. Back to this. So we've got a couple different things here. Whoops, not that big. Jeez. All right, so we got the temperature sensor. You can put these on here. So if everything is gonna more or less fit up here, shockingly, we might probably can just put. Let's see. Something like that, maybe. And maybe put the other mounting hole here. Might look a little weird, but let's see. Our 3D viewer doesn't have all the 3D models on here, but give us a rough idea. We have a stemma connector. We have our reset and boot button, which don't really like how those are placed. Don't really want to get too close to. Maybe something like that. And you have a charge. It's underneath the. Hmm. Like this a little bit. Okay. Do that. Let's see. Okay. Did I not put a. Definitely missing the RGB LED on there. Where did that go? Tools, updates. Hmm. Find a place for that. Could be interesting. Um, really don't want. Come on. Oh my goodness. Kind of making a mess of that, but okay. Those are connected. Okay. Oops. So let's see. Does that seem like a good place for an RGB LED? Um, maybe not any really better. Thing we could probably do. That one down here. Okay. That. I'm getting some of these up to where they need to go. Might be a little bit of a pain in the butt here. Um, good to put that one. Okay. Just kind of. So yeah, that one goes up there. Am I powering both of those off of the same GPIO? This one should light up. Guessing so, at least. Okay. So I made these a while ago, these little test ones. And the accelerometer one I made sure worked. And then I had made like some I had made like not firmware, but pin definitions and stuff for Arduino so that I could program it with Arduino. And then I updated my ESP32 Arduino library and it removed all that crap. So I need to make it again. So we can do that. I need to my icons real quick so I can find my. So we are gonna do that now, and I will basically show you how we do it. That's so if you ever like made your own ESP32 and you want to program it in Arduino, it's not that complicated, but you do have to make some stuff. So first thing we want to find is basically where that Arduino package or ESP32 board package is saved. So I have 2.07, which is the newest one. It'll be under your username, app data, local, Arduino 15, packages, ESP32, hardware, ESP32. And then in here, we're going to go to variants. The easiest thing to do is just to find a board that's like basically what you have, because, you know, as far as same chip. So mine is, this one's a ESP32C3. Let me find. So my B-Motion Mini has, I don't really have any pins broke out on that one, but maybe we can just, I'll just copy it and we'll see if we can get this working. So I'm just going to copy that one and paste it. Where'd it go? Okay, I'm going to rename it B Mini. Open this up. Then we got our pin Arduino. It's basically for the pin definition. So when you select your board, it will know which pins correlate to what. In fact, let me see if I can open this with VS Code instead of Visual Studio. Okay. So, and this one's super simple because I didn't have hardly anything in it for the B-Motion Mini. And all we have to do here is set up our pins that we have for our board. So let me get the, I'm gonna need this open so I can see which pins I've got and what's doing what. I'm gonna kind of set this off to the side, but just so I can reference. So, am I even breaking out RX and TX on this? I think I'm not. I don't think I am. Because everything is just programmed off of. Yeah, I'm using those. Because with the C3, it doesn't have very many pins on it, so it's kind of not a lot of pins to choose from. So we are not using those. Our boot button's still 9, I think. Yep. Now we don't have a PIR pin, but our power pin for going to equal 21. Okay. Our Neo pixel is 20, right? Yep, 20. Okay. Then we're just gonna do this. We're gonna go. Let me look at the other ones actually real quick. I can't remember how that was, if it's named differently or not. Variants. Right, okay, that's what I thought. Just want to make sure I was doing that right. It's not that, it's, so these are gonna be D2 equals 2. So you can just setting up our pins here. 3 equals 3. Now we got 0 as well. Not gonna be very many of these. 3. Oh, we got 1 as well. Okay. And then we have to name our SCL is going to be 10. SDA is pin 6. are, what's the other one? We're going to just say battery is 4 because we're going to try and monitor the battery. Ugh! Which on this one, my little test ones, it doesn't work because I put it on pin 5, which is ADC 2, not 1. So I've changed it for this one. It should be on ADC 1 now. I think that's it. GPIO, and we need 5 too, because we have 5. Oops. 5, okay. So let's save that. Make sure I'm not missing anything. 1, 2, 3. 9's going to boot. That should be it. Okay. So we got those saved. And then the other thing we have to do, which is not nearly as fun, is go back to, is it variance? No, go back to 2.7 boards. You have to open this. I'm going to use VS Code. This is a massive list. Like, it's the Word document or text document is just huge because it has every board that's in Arduino or in this library and like a whole bunch of like menu things you have to set up. So I'll show you. So if you can see, this here's the list. We have to add our custom board to this. Huge. So if you're ever doing this, easiest thing to do, because if you see on some of this stuff, and you might have to make the video big to be able to. Actually, I don't know if I can make this stuff bigger. Can I make this bigger? View, appearance rather. So would I make the font bigger? I'll see one. Zoom in, maybe. That again. Okay, yeah, it's a little easier to see. But you'll see how a lot of these have like ESP32S2, and you know, there's a whole bunch in here, a bunch of S2s. Feather S2. You want to find, you know, so basically find whatever chip yours happens to be running on. I'm using the C3, so let's try and see if. So here's a cutie pie. All this should be fairly similar. In fact, I think I'm just gonna copy this. So you want to, so everything between these hash, you know, break. This is where you break out the different boards. So between here and the next one down is what you're gonna need. So I don't think I need that, but we'll copy it just in case, just for the heck of it. Oh no, I went way too far. Or did I? Okay, so down here to the next one. So we're going to copy that. We're going to go to the very end of the program or the file. Hit enter, paste. So we're pasting this in again, but we're going to change some stuff. So this, they literally just name this. We'll just name ours the same thing. The easiest thing that I've found to do, let's do the same thing here actually. Be many. And we can, so I'm going to copy this, copy, control find. So it'll find all of them. And then we can hit the down button and then we can replace them with B mini. Let's just call it, yeah, oops, ESP32C3. And then if I hit enter, it should replace all those. I'm going to go to the end. Now, obviously, when you get to the end, you want to stop where it loops back up to where the original was because you don't want to override those. You just want to replace the ones that you're putting in yours for your custom board. So we come down here like that. Okay, now we're back up to the original one, which we do not want to change. We come back down here. Okay, so we got these. One thing we're going to get rid of is we're going to get rid of these because these the PID and VID are specific to that Adafruit board. We don't have, there's a way to get these for your own boards, but we don't have one for this board because it's just a custom one. So I'm going to delete that because I don't want to use theirs. I'm going to look at the rest of this stuff and just see if there's anything in here else that I need to change before we try this. All this should be good. Okay. We're going to hit save. And that should be all we have to do. So now, if I go to my Arduino and close it, and we're not going to save that, to open it up again. There it is. Let's see if that board shows up or not. It's been a while since I've done this, so I may be forgetting something, but we'll see. Tools, board, USB 32. Scroll down. There it is at the very bottom, which you can barely see it on your screen right here. So B mini, so we're going to select that. And then if I plug in my board, let's see. I don't have any libraries built for this yet. So I do have that sensor on there. Let's see if we go examples. Let's see if we can just use the Adafruit example for that particular sensor, which is, which one was that? It's farther down, I think. I think it's S. Where the heck? I remember that one not being under the Adafruits, I think. Oh, let me look. I'm just wasting time. SHT20, is that it? It's 40. Oh, AHT. Right? Samples. Yeah, it's at the very top. I just completely missed it. Okay. I have not tested this board with this built-in sensor, so we'll see if this works or not. But I've built, since I made that pin definition and named my SCL and SDA pins, which are I2C, when I run this program with my board selected, it should know which ones are the I2C pins on this that I've designated for it. And in theory, this should just work, in theory. Plug that in, put it into the download mode, port, and let's upload it. And let's, nope, didn't like that. What did I get wrong here? Yes, the file exists. Yes, it exists. ESP how? GPI, what the heck? That should work. Why is that doing that? Almost guarantee it's something wrong with this. Let me a second here. Find this. Okay. Think. Don't know if that's it or not. And I don't know if I'm going to have to restart this. Okay, let's close those. Okay. Samples. No, don't do that now. Close that. Mini. Okay, it is something wrong here. So 2.07 variance. Okay, it is underscore. So it should be that. Close that again. Arduino. Put that back up. Samples. There. Close that. See if that did it. It's off to a better start than it was a minute ago. Oh. So the S. Okay, so we have to name some. But doesn't like. So it needs those pens too, apparently. The SPI pens. Does it? Packages. Okay. I'm going to look at theirs real quick and see what they had for that. Okay, so they have these. I'm just going to copy it. I wonder if it'll let me do this without restarting. There we go. Okay, so it uploaded to our little board. Let's see if it actually spits anything out correctly. So port. There we go. We've got some data coming out, so that works. Is it accurate though? Yeah, temperature and humidity went up by breathing on it. Cool. So that little test board actually does work. So now, so for basically for all these other versions of it, I should be able to use the same pin definitions board. So I don't have to make a unique one for every board. I'll just have to make unique libraries for each board, if that makes sense. So right now I'm just using an Adafruit library, which is fine. You know, you could do that too if you wanted, but I'd like to try and make it as simple as possible where I just build all that into the particular library for this thing. Okay. So that works. That's cool. So now we have that pin definition board. I'll try not to update the library because if I update it again, if I went to 2.08, whenever that comes out, it'll overwrite whatever custom stuff you put in there. So, all right. So we still have to lay some tracks here. So reset's way the hell over there, so we can actually swap these around. I think that makes more sense to do that. Whoops, 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 whoops. Come on. So the only thing I'm not really sure about with what this is, come down a little bit. Is where am I going to put the text? And actually, I'm going to change. I'm not going to use those text ones. I'm going to use something different. But could do something stupid like put the RGB in the middle of them. Would that be dumb, I wonder? Putting the RGB in the middle of them. Oh, excuse me. Where else am I going to put? That up there. Edit this footprint. So I want to get rid of silk screen. So whoops. Okay. Do something like that. Boot and reset. Might actually be able to put, you know. Something like that. Guess that. Let's see. Okay. Let's move this up a little bit. See if we can't get that ground to reconnect. It does. Okay. What's going? Arm only, apparently.
Arm only allowed on the screen.
Yep.
What you do?
I'm designing more boards.
More?
Yeah, different types.
What type now?
No, these are different sensor types. They're basically these, so I'm just making them.
Did that come out of the card I gave you?
What?
The audio one I gave you. From the card.
No, these are different. Sorry. I was like, what the hell are you talking about? Yeah, yeah, you did.
I'm just gonna buy you a little audio card now for.
There you go.
Alright, let's leave you alone.
All right. Okay. Let's see here. There's 9. So let's move this up. This is getting kind of clunky here. Try and come straight down. Holy moly. Let's move that over a little bit. Okay. Okay. I don't know if like with PCB design, like if what's perfect or what's like the greatest ideas, but since this is a 4-layer board, I'll try and trace on the top and mainly, but if I have to go to the one of the two middle layers, one layer I use for vertical traces and the third layer I use for horizontal. So like all my green traces should be going north and south, and then all of my orange ones, which are the third layer, should be more or less going side to side. It makes routing things I've found a little bit easier. Then you can always use the bottom layer if you absolutely have to, but so but again, I mean there may be better ways to do it, but that's just how I've found works best for me. So that one's way up there, isn't it? Yeah, it is. Man, I don't know. I guess we can leave it there. So NeoPixel needs to go all the way up there. So what we are going to do, we're going to grab this trace. And I don't want it. Oh, no. Trying to clean this up a little bit. Okay. And then, so we got our NeoPixel. So let's see. Let's go there. Here. Let's go there. Yeah, green. Okay. NeoPixel should be similar. And actually, I'm gonna move this because that's okay. Okay. Oh yeah, that was the other thing. I'll have to build a library for that. I probably should make sure that the actual RGB works on this setup before I get too crazy here. Oh, that one's not right. That needs to be now. Probably should put that on a different pin. Do I have any extras available? 7? Am I using 7 for anything? So probably shouldn't. I was thinking about putting the stemma connector on a GPIO pin. GPIO pins work for like if you just want to power something like like an RGB LED or a sensor. But with the stemma connector, the Adafruit boards, which is what they're meant for, they can be stacked together. And so if somebody tried to plug in too many of those, it could brown out the board, I would think. So it probably should just be on the LDO. Even though if you plug in, the only downside of that is that when you plug into like a board, even when the board isn't on, it will still draw a little bit of power. But that is what it is, I think. So we should change that in the schematic because it's not right. There's a stemma connector. And that should be 3.3. That. Okay, save, tools, update schematic. Okay. So those are fine. What is that doing? That's okay. That's going from ground to ground, right? Yep. So what we can do is we can just put a via in here. Maybe. Or not. Why is it not? There we go. That'll connect those. In fact, having a couple of these is not a terrible idea. This just connects the ground planes from one side to the other. Okay. So we got all that. So we need to connect the stemma connector. And damn, that V bus needs to be connected because that would be bad if you didn't have that. Okay. Let's actually. Okay. So we need to connect. And those grounds are not connected, but we can fix that, I think. In fact, we might just be able to. Can we go through? No, we cannot. Just do something like that, maybe. That'll work. Yeah, that'll work. Okay. So now we need to get our SCL down there. So let's go green to go south. So when we get down here, go across. Okay. Then SDA is going to be the same way. Come down the center here. Then go across. Okay, and then we need to connect our 3.3 volts. I don't know what that's trying to connect to. That's weird. So that's 3.3. We can just do this. Okay. Okay. So let's clean up anything that's all right. Let's rebuild everything. Let's do an inspect. Although it's gonna find out those aren't connected to probably anything. Hole clearance violation, board setup constraint, yada yada yada. Yeah, that's literally the footprint. Yeah, we don't care about silk screens. We don't care about. Yeah, we don't care about that. Don't care about those. care about that. Don't care about those. Okay. And then unconnected, we have where are these connected to? So now, how do I do that? Enough fix. Okay. Yeah, it's always a good idea to run your design rules checker because it'll find any little connection that's not connected to something. Ah, those grounds are not connected. Okay. Which shouldn't be too big of a deal, I wouldn't think. Let's do this. Just connect it like that. Okay. Run it again. Thermal relief connection to zone incomplete. Okay. Good. Okay. So the back silk screen. Or let's just do humidity. Temp. And humidity. I wonder if I should name it or actually just put the sensor, like what the actual sensor product number is. And we'll do this for now. Okay. The other thing, let me look and see if there's any updates to uh think so. The buzzer thing isn't working on KiCad 7, but it is in 6. KiCad. So the annoying thing is I kind of have to like, oops, use it in KiCad 6 and then copy and paste the stuff over. So, see if I can open this up. Pay attention to that. That's an old one. Okay. And so let's go reset. Okay, that didn't work. Why didn't that not work? Did I open the wrong one? Try it again. KiCad 6. There we go. Copy. Oops, no. Paste it over there. Paste it over here. Make it look a little fancier. And boot. Same thing over here. Stupid thing. Okay. Okay, got those. RGB. Let's make a charge controller one. Maybe. I don't know, will it fit down there? I might need to come up here. Okay. And let's okay. Let's take our little charge. Let's see how that would look. Okay, that's not bad. All right. This one is the... I love putting the product name up there. Might be kind of a pain in the butt. I don't know. The other thing I want to make sure is that our mounting holes are in line. And it looks like they are. It's at 90 degrees exactly. Down a little bit. Okay. Feedback, ground, GPIO 0, 1, 2, 3. Okay. Save that. Do our design rules again. Unconnected. Yes. Why do we do that? Your unconnected items on your DRC is really the important thing. These are more like just visual. You know, or they'll tell you like, hey, you got things overlapping or something. Ignore all those. Oops. Whoa, that's not what I wanted to do. Exclude this violation. No, there we go. Okay. Run again. Okay. So I'm going to save that. Okay, so this is the temperature unit. Let's make a... I'm thinking about it. A text. Do the version 1.1. I will usually put the version number underneath the USB connector. That way, when I have blank PCBs, I know what version it's supposed to be. But it doesn't clutter up the board for the end user. Okay, so got those. The other thing we can do is let's make a couple more. And let's do padding. Maybe like that. Let's go CL. CL. Nope. And that's not going to work. Uh, the other way. we go. Okay. So I'm going to change the ones on the bottom. The A. Okay. Okay. So let's go bottom. Delete these. So SCL. SDA. Oops. 04. Okay. Then let's go ground. Okay. 2 grounds here. Then 3.3, oops, 3 volt. Oops. Then 5 volts. Okay. And then the other side as well. You change these around. So if that's like that, that's like that. 3.3 volt. Okay. VBATs. Putting it on the bottom. Go. Ground. We got 0, 0. Delete. Oh, 1. Getting these kind of sorted out here. 2. Kind of nice if those are in order, but I have to go over 1. I wonder if I should do that. Might make it look a little nicer. So swap these around. Save tool, update. Okay, go 2. There we go. Let's go back. And then finally, 3. save. Let's see how this looks. Okay. Okay, yeah, then we got that thing in the way. It's a good thing we checked. Okay. All right. Do I have that on the bottom too? I do have that on the bottom. Okay, save that. Okay. So this is what the bottom of it will look like. In the front. Okay. Um, it would be nice to be able to get let's see. Okay. G and D. Let's see how this would look. Okay. Yeah, we might be able to get away with that. Three. Oh, that's kind of a close one. Hmm. Always nice to try and put those on the front of the board, but I don't know if they're gonna fit. Oh. Don't know if it'll be good out here or not. Maybe. Maybe those will work out there. Yeah, let's try it. Whoops, not that. Ebats. Okay, we got those. And then we need SCL. SDA. All this little fiddly stuff that takes forever. 05. And 5 volts. Okay. And then okay. A 1. Two. And 03. Okay, let's see how that looks. Okay, not bad. Whoops, did not mean to do that. Okay. We can maybe even change. Let's just see how this looks. Oops, come on. Be many. And let's go 3. Let's go 4. 4. And it's definitely not big enough. Oh, that's why. 3. It might be. Let's see. 45. No, yeah, it doesn't like that. So now let me rotate these. That one does. Minus 45. There we go. Nope. Minus 35. That is considerably bigger than what I was expecting. But yeah, let's go like maybe just a touch smaller. So height, let's go 2.5. Okay, go here. Minus 135. That's maybe a bit better. Let's get rid of that. Let's put this. And see what that looks like. Maybe still a bit big. Nope, not that. 2. That's maybe a bit better. B mini. Okay. Yeah, I think let's grab that kind of up out of the way. course, that's now not connected. Um, Close. You just connect already? Go. Okay. All right, we got those. Uh, so let's save that. That one will be a little bit. Yeah, no, it's not that bad, I guess. Jesus. Okay. Awesome. We got that. The other thing I probably should just double check is make sure that the RGB LED is going to work. So, libraries. Let's just copy. Gonna be many temps. Is that the one? Let me see what this is. Yeah, that might work actually. Let me double. Okay, so let's go here. I guess I made one before. Let me see if it'll actually. Temp RGB LED. Hopefully. Let me open that again actually. That's not going to work because that's not the right one. But, where's that at? I feel like that's not right. I think it's just power. I think it's just power. And then let me see if there's Neo Pixel. No. No, let's see if that close those. Go back to Arduino. And okay. So I'm gonna put this in download mode. Tools, port 166. We're gonna change the board to B Mini. Upload it and see if that turns on my RGB LED or not. I don't even know if the RGB. No, I didn't like that. Well, that's right. I need to get rid of that. It's not gonna work. So get rid of. Get rid of those. We don't need that right now. Get rid of these. Okay. Save. Close that. You know. Try it again. Yeah, less channel. Don't have that either. Oh, where is it at? Get this figured out eventually. That's why. Let's go RGB data. Let me change that to NeoPixel. This is whatever you've named in your pin definitions folder, which I had named it NeoPixel for whatever reason. So I'm gonna change that. I think that's it. I guess. Save it again. Restart it again. And try and upload it again. Okay, that worked that time. So let's. Hey, it works. That's good. Our RGB works. And just a reminder, this is the first revision of these boards, and what I've been working on is the second revision, but I hadn't tested the RGB on this setup yet. So, okay, that works. Cool, cool, cool. So now we have all that. Everything's connected, all right? Let's go tools. Let's just run this again just to be on the safe side. Yep, okay. So let's take these and delete them because I don't need those in there right now. Update schematic. Okay, get rid of those. Let's run our design rule checker again. Okay. Oops. I don't think anything popped up. Nope. Okay. All right. Got that. So now we've got that one. Close that. Go here. And actually, I need to go to my where I have these saved at. Boards. Let's go. Copy that. Paste it. Rename it to Be Many. Let's see. What were the different ones that I had? I had gesture. I had just spent, I don't know how long it was. Altimeter. That's the other one I want to do. Now, hope I spelled that correctly. Okay. close all that. We should be able to open this project. Let me see if I can. Oh, I guess I should have just done that. I don't know what I'm doing. Let's delete that. So we're here. Save as. We're just going to save it as a new one. Be many. Now, altimeter. Hopefully I'm spelling that correctly. Did that do anything? Close that. Let's try this again. Let's go here. View. List. I don't want KiCad 6, I want KiCad 7. Open with. Then file. Save as. Altimeter. There we go. There we go. So now if we open up here. Oh, geez Louise. Back. Ports. Altimeter here. Project open with KiCad 7. There we go. I don't know why I didn't like that. Oh my goodness. Why is it opening up 6? I want 7. Open with KiCad 7. There we go. Okay, so on this one, we can get rid of the temperature sensor because we don't need that. And let's go with the GSP. Or what was it? No, we got that one too. No, I don't remember which one it was. DPS, that's what it was. Okay. Oh, these have. How do they have that set up? Says not. I'm gonna look at their data sheet and see what they have because something's not jiving here. Huh. That's weird. Why would they? So on their DPS 310 schematic, they're using a BMP 280, which is not correct. Interesting. Very interesting. What about this? Might be the same thing. Loads. That looks right. Let's try that. Ultra Librarian. LSP, LPS. Okay, KiCad. Oh, yeah. So this is a different um altimeter, but I want to make sure that it can report. I shouldn't say altimeter. It's a pressure sensor, but I want to make sure it reports um the altitude. Some stuff doesn't. You get close all these windows out. Here, KiCad, parts, new window, LPS 22. Put these in here. Okay. Create a new one. User, import symbol, parts. Okay. Save. And then here. User, import footprint. Okay. Let me look at my I thought I had it's not the same one, but let me look. Samples. Okay, should be that one. Examples. Close all these. And here. Okay. I already have one of those. Okay, so let's unplug that. Then I have one of those floating around here somewhere. LPS 22. Let me see if I find what I did with that one. Right there. I haven't even opened it yet. Still in the packaging. Okay. That. There. Plug this in. We'll see if we have as much issues with this one as we did the other one. Okay, and that is this one. Don't need that. Put that in there. Okay. I want to see if this one will report just pressure. I want to know if it does altitude. PS 22. That threshold, begin SPI. Hmm. There's our pressure. Not really changing much. There it goes. OPS 22 get altitude. I did not spell that correctly. Let's see what they say here. That doesn't do anything. Um, I'm literally just kind of like looking to some docs here to see if I can figure out if somebody else has used this to measure altitude. Um, so, okay, altitude. We can try this. Let's see. It's POW. Uh, so pressure. Okay, let's get rid of those. We'll see if we can make something work out of this. Pressure, not pressure. This is really the... I don't know what the POW stands for. Oh, okay. So this should be... we'll say 991. Oh wait, no, pressure. The that number. Oh wait. Nope. Let's do 500. I don't know what the PO. I need to figure out what that means. Okay. See if this breaks anything. Oh my goodness. Yeah, it did. It accepted that, so we'll see if it actually spits out something that looks right. I always compare it against another sensor that does automatically show altitude, but we'll find out. Okay. Reset it. Nothing yet. Oh, could try maybe a different different library maybe. S35, S22. Hmm. Let's just see what this spits out. Okay. That just shows a pressure. Yeah, it's not doing anything. Uninstall that. Okay. Okay. There we go. Minus 24,000 something. Which does not seem right. Um. Do I have the SSGP? Yeah, it does have Be nice to know what they were doing with that. Let's go back. DPS 310. Oh. Huh. So the reason why they use the 280 is because it's the same exact size and pinout, which is interesting. So how did that work with I squared C? Okay. That one they've got 1 and 2. Those are the same, so these are both ground. Um, 6 and 8. Those are both. 7 is. There's no 7, but we'll just make a ground, I suppose. That's 3.3. And on these, we actually want to name it power. Whoops. Round. Okay. So SDO is a SDO/address, whatever that is. SDI. And SDK. That's interesting because okay. So wait, SDI is SDA. And SCK is SCL. Okay. All right. Those mean the same thing then. And SC or CS rather is what? Sure. Okay. Don't know if I need that. Try without, I suppose. Okay. Update. Okay. Oh, I didn't do that. Save. Oh. Helps if I give it a footprint. Turn all this nonsense off. User, here we go. Okay. So this we can we got ground, we got power, ground power. Do something like that maybe. Oop. Okay. Um, okay. No. Okay. All right, that should be connected. What it's worth. Then the only thing we should have to change on this is the back silk screen. Oh, let's see, meter. Let me just double check I'm spelling that right. Yes, okay. View, previewer. Maybe move this at the end. Actually, it looks like that's not rotated correctly. Minus 46 maybe? Nope. 43. Yeah, looks a little better. Okay. Save that one. All right. So, we've been going for a while. So I've got an altimeter, I've got the temperature sensor, the accelerometer is the other one. Just let me look and see what I had before. File, open project. What the sensor was. There it is. I'm going to copy that. Close. File. Open project. btemp, open this file, save as, board, go. B2. Okay. Open these up. And this one we're going to delete. And then we're going to paste that in, save, tools, update. Okay. Do this again, basically. Okay. So SDA all is off. So SDA. SDL. Let's power. And let's do this here. Tools. Okay. Look at those. And we can change back here. Whoops. Copy that, please. Accelerometer. Okay. Save. View. 3D viewer. All right. Got that one. Yeah, once we kind of got everything set up, you know, swapping these out shouldn't be that difficult. Trying to think what the other ones were we had. I'll have to go through and clean these up, but in fact, I probably should have cleaned up the first one, and that way they'd all be right. But so let's see. All fours, okay. These aren't too far off, but still. Let's see. What was the other ones I had in the user? I'm trying to remember. Got that gesture sensor. What is the BA? I don't remember anymore. BH. That's the light sensor. BH gives us a lux. So let's save, close that, file, save as, boards. pH 1715. Okay. Of course, that's not very well. So one is 3.3 volts, which we are going to do power for ours. Two's the address pin. We got three's ground. I probably should go through and add those. That one has seventh one. What the hell's 7? 6 is SCL. 4 is SDA. And 5 is a divider of some sort. So this one's a little bit different. Go. Now I wonder if I can put that on power pin or doesn't need to be on the 3.3 volts. And the only big difference with this one is that it needs a 1K resistor here. Okay, save, tools, update schematic. No, don't have the user. Save, update. Yeah, that one only has, oh, 7 is like just a pad. I'm assuming like ground or something. Okay. So let's clean these up a little bit. We're gonna do it like so, I think. Uh, okay. And since this one is coming off of 5. Yeah, so that one's not technically going straight to move these over a bit. Of course. That. Oh, what's the other thing I'm forgetting? Need a 1 UF capacitor right there. Save, tools, update. Okay. These up here, I guess. Let's go like this. That one's gonna be up there. That one's gonna be here. Down there to there. Okay. And okay. Save that one. Then this one is going to be light. Three viewer. Whoops. Did I move anything? Nope, just that one. Okay. All right. Oh my goodness. All right. Okay, I've been going for quite a while. What is this? 3.5 hours. So, thank you if you watch this live or if you watch this after the fact. Just been going through designing some new boards for this family of boards. Little B minis, as I'm calling them. We're gonna have different sensors on them and stuff. Let me open this up. Nope, don't cancel that. Main camera. And that's it'll focus on my hand. This is the first revision in my hand. I've just gone through and made a second revision on a couple of them. So I will try and get these ordered soon. As far as other stuff going on, I've got some other stuff that should be showing up sometime the next week or two. It's a different product entirely that I'm excited about. The B-Motion S3, I've finished production on, finally. And getting them ready to be packed up and sent out to Crowd Supply. Got my little cards in the mail the other day. So that's cool, the little pinouts for the B-Motion S3. So those will be shipping soon. Yeah, got lots of stuff in the works. It's been a busy couple months, but I'll try and stream a little more frequently if I can. So thank you for tuning in, and I will see you guys in the next one. Bye. I don't know why I'm looking up. My monitor's up here, and I'm looking up at the screen, but you're actually over here, so bye.